Can anyone get us started? What would you write first? Just give me what would you write first? Wonderful. Remember, you don't have to do anything. Just find the x and y intercepts. You don't have to rearrange anything. You don't have to multiply by anything. You don't have to do anything. Just find when x is 0, plug in x is 0, find y, and vice versa. Can anyone give us the x and y intercepts? I'm just changing the attendance because Jonathan was late, so it was already absent, so I'm changing it to present. Okay, done. I don't want to forget.
Can I take that quiz?
He's funny, isn't it? Isn't he?
You said you were with me last time.
But I said 15 minutes.
Oh, okay.
You were late 45 minutes. I'll wait 5 more minutes next time. Promise. Okay, when x is 0, how much is y, please?
0.
0, comma 2. When y is 0. Yes, I agree, because you move 2 and multiply by 2. Very good. So x equals -4. So the ordered pair is? So please plot the points and extend the line. And then pick 0, 0, because the line does not pass through the origin. Pick 0, 0, and graph or shade in the region. Is it a solid line? Yes? Good. Please don't forget to extend the line. This is not the inequality, so please do not write the inequality on the equation, because this is not, yes, Michael? Okay. So it's clear that when x is 0, I cover this and I get y equals 2, correct? So when I have y equals 0, 0 equals 1/2 x plus 2. I move to -2 equals 1/2 times x. Multiply both sides by 2 to get x equals -4. Better? Perfect.
Can you explain what you're doing when you're plugging in 0?
I'm checking. So I pick a point in this area. I will pick the origin, and I'm checking whether I get a true statement. So when I get 0 greater than or equal to 2, I know it's false. So no other point here will verify the inequality. If this one did not verify it, no other point will. So I have to choose the opposite. Is that better? So I shade in the upper. Really? Okay. 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 I know, they're dying, they're all dying. Good. So all this and the area y greater than or equal to 1/2 x plus 2. So I have to be silly more often so I can wake you up. Yes, Brianna?
I still don't understand how you're figuring out where to shade.
Okay. So I pick this point. I plug it in. I got a false statement. If this point doesn't work, no other point in this area will.
Okay.
Check with any other point. They will give you a false statement. So you have to shade the opposite.
Okay, so then say like for that one problem that did run through the origin, you just pick a random.
Another point anywhere you want, but you have to remember where you picked it. Because if you picked at the top or above and it gives you a false statement, then you choose the opposite.
Okay.
If it gives you a true statement, then you have to choose that area.
Okay.
Good. So now the other one. And the other one is y equals 1/2 x minus 3. When x is 0, y is, so this is 0, -3. When y is 0, take a moment, plug it in, and give me x. Will I get rid of these? I have a bunch of them, and I just left them somewhere, and I can't find them, so I'm going to have to get more. Ready? So how much is x when y is 0? Yes, because I moved -3, I get 3 on this side multiplied by 2. So x is 6. Perfect. So now I have 6, 0. And 1, 2, 3, 4, 5, 6. And 0, -3. Okay? 2, 4, 6. Okay. Now, before I draw, for a moment, let's look at this equation. And let's look at this equation. Do you notice anything before I draw this? Thank you. What does that mean? Thank you. It's funny. Okay, so this equation is y equals 1/2 x minus 3. Now, it doesn't pass through the origin, so I'm checking the top region with 0, 0, 0, 0, 0 less than or equal to -3. True or false? False. 0 is not less than or equal to -3. So I cannot choose this, I have to choose this. So this area is y, it's less than, right? Yeah. Y less than or equal to 1/2 x minus 3. So now I want to intersect these two. Please intersect them and tell me where they overlap. Please.
Is there any way for us to tell, like, if they're parallel or if they will intersect?
Yes, from finding the slope.
Since they're parallel lines, they will intersect.
Right. No, they will not intersect because the regions don't intersect, not because they are parallel. So look at this for a moment. This could be this one solution, and this could be the other.
Okay.
But in this case, it happened that they were away from each other, and the lines were parallel. So we cannot assume that if the lines are parallel, the solutions to inequalities will not intersect. Perfect. So in this case, solutions what?
Zero.
None. So no solutions. The two regions do not intersect. So we will not be able to, if we have a business that we want to establish, and we have two conditions, maybe the number of people that we can hire or our resources are limited somehow, we will not be able to create our business if these are the two options. Any questions? Any questions? Okay, this completes. Maybe we should do just one more.
How would you know if, like,
Yes.
there's infinitely many solutions, like other graphs, like,
For infinitely many solutions?
like the same lines?
Same line, that's one option. But these are, in general, infinitely many solutions. This is still infinitely many solutions, right? There are so many that I cannot even count them. This goes on forever. So they are infinitely many solutions. Yes, Jonathan, go ahead.
I'm waiting for the next one.
Okay. Happy to hear that. And I'm going to choose, 68. And this is 3x plus 2y less than or equal to 6, and x less than 2. So then let's work on this for a minute. And then we'll move on. Okay? So the first equation is 3x plus 2y equals 6. Can anyone give us when x is 0 and when y is 0? So when x is 0, yes, very good. And when y is 0, x is so 2 comma 0. Ready to graph? So 2 comma 0 and 0 comma 3. Solid line or not? Yes, I agree. 3x plus 2y. Good. I pick 0, 0. It doesn't pass through the origin, so I'm checking the left-hand side. So is 0 less than or equal to 6? Everything, including points on the line. Make solutions to 3x plus 2y less than or equal to 6. Now I need to graph x equals 2. How do I graph x equals 2? At? Very good. Solid or not? Good. Now I don't need the point. I only read. Whatever points, but they can have any y value, but x must be less than 2. So now this divides the entire plane into regions, to the right or to the left. But I want x to be less than 2. Bless you. Which region will I pick? Very good. Thank you. So this is x less than 2. Do these two intersect? They do or they don't? Yes, they do. So it's this line. It's this line and close to this line, but not that. So this line, but nothing on this line because it's a dotted line, and everything in between. So this is the area that solves both. Any questions?
So your final answer for each of these questions is
The region.
is just the shown graph. with
Exactly.
shading.
There is nothing, how will I explain it to you is in words. Oh, to the left-hand side of this line, but below this line, and so I would not have words for that. Exactly. So that's the only option. That's why this is almost never true, right? These two are almost never true. When we have to solve, I have to graph, right? Solving is one thing, graphing is something else. But when it comes to systems of linear inequalities, this is what I need to do. When I'm asked to solve, I'm asked indirectly or implicitly to graph it. Because there is no other way. Very good. Chapter 10. So let me show you where we are at this point. So we completed this. So we have to look at these 7 sections, and then we'll set up the next test. So we're starting chapter 10 right now. Chapter 10 deals with radicals. Any questions? Katie, go ahead. Radicals, this chapter has 7 sections, and I have to be honest with you and say the first 5 sections are no fun, in the sense that we have a lot of work to do on the rules and laws of radicals, what they mean, how we graph them, and they have tons of little rules that we have to understand and use. I'm going to try to, if possible, avoid those types of problems that you will never ever see again. But I have to focus on the ones that are basic and very important. you can do the same thing if you want with the other one. Okay? So, let's start radicals. And the first thing that we have to start with is define what a radical is. And this is the most general form of a radical. I'll explain everything. This is n, lowercase n. This is lowercase a, lowercase m. So this is what we call, and I'm going to write it down how we read this. The nth root of a raised to the mth power. The nth, this is the index, so this is called index. This is called radicand. Everything that you see under the root bears the name of radicand. And this is the radical symbol. Radical symbol. Now, let's talk about the index. The index, which is n, can be 2, 3, 4, 5, and so on and so forth. It cannot be 0.3, it cannot be 1, it cannot be 0, it cannot be a negative number. Can you encounter some other situations? Yes, but in general, that's the way we define radicals.
What's the n?
So, so this is index, radicals, the nth root of a raised to the mth power. Radical symbol is this, the radicand, and index is lowercase n, 2, 3, 4, 5, and so on and so forth.
So it can't be a decimal, 1 or negative?
It cannot. Okay, so let's start with this notation. We do not, by convention, we do not write the smallest index. We know it's there. So we read this, the square root of 4. So when you see no index, we mean the square root. So the square root of 4 is 2, since, careful, 2 squared is 4. 2 squared is 4. Now this is the cube root. The cube root. So the cube root of 8 is, since to the third power is 8. Bless you. What do you think? What do you think? 2. Very good. It is 2 because 2 to the third is 8. What about the fourth root of 16? The fourth root of 16 is, since what? Very good, because 2 to the fourth is 16. The square root of -4 versus the cube root of -8. This is a very important note. After the notation, which I will come back to in a minute, this is the most important note. How much is this? So I'm going to ask you, what number, oops, what number you squared to get negative 4? You can't. Very good. So I will say not real. It doesn't exist. It's imaginary. We'll talk about it later in this chapter. Yes, please, Michael.
Is that a, say, square in the middle there, like in this one?
This one?
No, to the left, like in the middle.
I put a question mark. Since.
Oh,
So I have here the cube root of 8 is 2, since 2 to the third is 8. Then the fourth root of 16 is 2, since 2 to the fourth is 16. What about the cube root of negative 8? So dot dot dot, since negative. So something to the third power is negative 8. Is there a number that I can raise to the third power to get negative 8? Negative 2. So negative 2 times negative 2 times negative 2 is negative 8. So this is our first note. Note. When we take an even index root, it must be from positive or 0. The answer will be positive or 0. But when I take the cube root or any odd index, what can I have under the root? What else? How much is the cube root of 0? Which number you take to the third power to get 0? Good. How much is the cube root of 8? We just had it a minute ago. Right. So under an odd index root, you can have anything. What will be the answer? Also anything. So what do we conclude for now about odd and even indices? One of them, one group is friendly, the other one is not. Which one is friendly, which one you like, sort of? Yes, these I like. No worries. No worries. Anything goes, right? No worries. The first one is tricky. Every time the index is even, I have to make sure that two things happen. One, first, the quantity under that even root is positive or 0. And I have to make sure that the answer is always positive or 0. If you remember, we even had on the test a function that was the square root of x plus 3. It started at negative 3. What is the range of this function? What is the range of this function? Can anyone give us the range of this function? I know you know. 0 to infinity, correct? What is the domain of this function? Right, but 0 to infinity, right? I cannot have anything else but 0 or positive. That's why you wrote x plus 3 greater than or equal to 0. Because this must be positive or 0, right? So this is a tricky situation. Even index, two worries. Positive or 0 under, positive or 0 as the answer. Odd index, no worries. Anything goes, anything goes. Is this clear? Okay, moving on. The next very important note. This is crucial here to understand this part. Any root can be changed into an exponential expression with a power that is a fraction. We call it a fractional exponent. And vice versa. I will explain in a minute right now. Any root can be replaced or changed into an exponential expression with a fractional exponent, and vice versa. Danielle, can you see? Should we pull down the... It's right there in the back. Jonathan, can you pull down the shade, please? Thank you so much. Great. Better?
Yeah.
Good. So any root can be changed into an exponential expression with a fractional exponent and vice versa. So the nth root of a to the mth power can be rewritten as a. This is the power, the numerator of the power, and this is the denominator. And vice versa. So this goes back and forth. So the nth root of a to the mth can be written as a raised to m over n. And any exponential notation that has an exponent that is a fraction, it represents a root. If the exponent is 5, that's not a root. If the exponent is 2/3, that is a root. So let's go back and forth with this notation now for a moment. So if I ask you the cube root of x squared, how will you change this into an exponential notation? What would you say? X raised to 2 over 3. Very good. Now, if I ask you change x to 1/3 into a root, what will you say? Yes, or the cube root of x to which power? 1. It's 1.
Oh, my bad.
That's okay. Very good. Now, what if I ask you to change 3 to the 3rd power into a root? What will you say? You will say, sorry, it's not a root because the exponent is not a fraction. This is not a root. I can't change 3 to the 3rd into a root. That's just 27. That's not a root. Okay, now we go into rules of radicals. Rule number 1 is the one that I just mentioned. The nth root of a to the mth power is a to m over n. Here's the second rule. I'm going to use the square root, but it will be for simplicity, but any root will behave in the same way. So if I have the square root of a times b, I'm allowed to split it. What do you think about the ratio? Wild guess. Say it again. So how will I split the square root? The square root of a product is the product of square roots. What do you think about the square root of a ratio? What could it be? Just give it a shot.
Square root of A over square root of B.
Thank you. Absolutely. It's the same procedure. Basically, split the product, split the ratio. However, the square root of a plus b cannot be split ever. If the radicand, this quantity is the radicand, is a addition or subtraction. So you can split a product, you can split a ratio, but you can never split a sum or a difference. So let me give you an example. The square root of 9 plus 4 is the square root of 13. It's not the square root of 9 plus the square root of 4. So please do not make that mistake. It's very tempting But it's not allowed. It's not possible. The square root of 9 is 3 plus 2. It's 5. 5 does not equal the square root of 13. Any questions? Any questions? Okay, number 5. And then we'll look at some examples. What will you say about the square root of x squared? Maybe I should stop for a moment. I'll come back to this. Let's look at some examples and then we'll come back to number 5. Oh, I forgot to mention one thing. Between now and Tuesday, what I would do, I will find a time to go through everything in chapter 9 under highlights. Here is the topic and here are examples. Topic and examples, and so on and so forth. Topic and examples, and I will do all these problems from the review. Just to make sure that I got chapter 9 under my belt once before the test. And I will do that every weekend. And I will do the same thing with the test. I will print it out 10 times, and I will work on each and every test from now on till the end of the semester before the final exam, just to make sure that I don't have to struggle before I take the final exam. Okay? So I would like to work on some problems, and I'll come back to law number 5. On page 593, I would like to start with problem 12, which is the square root of 64y to the 20th. We're asked to simplify, and we're told to assume that everything is positive. I'll explain in a moment why we're told that. First of all, I notice that this is a product, and I will be using one of the first rules that I know to split the product into a product of two radicals. I know that the square root of 64 is good. And now I'm using another property which allows me to simplify a radical, because I know that any root can be written as an exponential notation with a fractional exponent. So I will copy y, and now let's figure out the exponent.
Is that 8 times 1?
So 8 comes from here.
No, I said, is that 8 times 1?
Here.
Yeah.
It's a product here. It's a product here. It has to stay as the product. So y to which exponent?
20 over 1.
But is the index
20.
is the index 1? Can the index ever be 1?
Oh, no.
No. So then 20 over 2 is 10. That's it. So this is the simplified form of this radical. Perfect. What about 25? The cube root of x to the 12th. I only have one rule. Yes.
So if there's no index, do you assume it's 2?
Yes. So that is the only one. So when we looked at the square root, when we look at the square root of 4, I mentioned that this is the only one that by convention is not written. Everything else has to be presented. If it's cube root, fourth root, they have to be written. But the only one that is not written is 2. And that's the lowest possible index. Okay, perfect. So the cube root of x to the 12th, what would you say? This is, I copy the base, and what happens with the exponents? Which is? Very good. Excellent. 27, which is the cube root of negative 27 x to the 9th. I'm allowed to split it because it's a product. So this will be the cube root of negative 27 times the cube root of x to the 9th. I apply the cube root of negative 27 and I get and I get careful. I get, what do I get?
So like 3 to the third or something.
Right, but it's negative. 3 to the third is positive 27, right? Very good. And then the cube root of x to the 9. Yes, it's x to the third. So this is the simplified form. Very good. Okay. What about 37? And then I'll come back to number 5. The 6th root of 64x to the 12th. The same idea. First, I see it's a product. I'm allowed to split it. When you split it, please remember to copy the index. Because if you don't copy the index, you're changing it automatically into the square root, and that's not the case. So, which number I raise to the 6th power to get 64?
No. 2? Just
And the 6th root of x to the 12th is? Very good. Now I'm ready for number 5. I wanted to practice the previous laws before we move on to 5. Okay. So, based on what we just practiced, what would you say the answer would be?
Should be equals x.
Correct. Should equal x. Now, careful to one thing. Let's go back because this is extremely important. Once we understand this, you will have no difficulties with roots. So please pay attention for a second. What did we say about even index? We have to guarantee that this amount or this quantity is excellent. Is this positive or 0? It's x squared, right? Good. The second thing I have to guarantee is that this answer is right. But what if x is negative 3? Will this be true? So negative 3 squared is 9. So the square root of 9 is negative 3. Is that correct? No. So this is not correct. So I have to make an adjustment here to make this true for any x real number. Any real number x. What is the adjustment that I have to make? One more time. This is already guaranteed because it's x squared. But this is not guaranteed because it's just x. And x could be negative 3. So I can't because 2 over 2 is 1. I cannot change this into 2. Right? But I can make an adjustment. And the adjustment comes from chapter 9. Let's think for a moment. What is the adjustment that I have to make to guarantee that also the other side is always positive? What did I study in chapter 9 that will be? Thank you. Now this is true always for any x real number. Thank you, Eric. Okay, so here are the possible options for law number 5. So for law number 5, there are 3 possible options. If the index is odd, do I need the absolute value in the answer? Will I ever think of using the absolute value in the answer? Don't answer yet. Let me refresh your memory. Will I ever care to use the absolute value in the answer if the index is odd? No. Excellent. So I will say, don't care about absolute value. There is no need. Okay? What if I have this situation? This is an even root, but what is the answer? Right. Does x squared ever need an absolute value? No, because x squared is always positive or 0. So if the answer, even if the index is even, but if the answer does not need the absolute value, I will not use the absolute value. It will be a mistake to use it. So I'll put myself a little note here. Even root, but positive answer always. Therefore, I don't care about absolute value. There's no need. And there is a third option. Here's the third option. Even index. So let me read the second option one more time. Even root, but positive answer always. There is no need to use the absolute value on x squared, even if the index is positive. But the answer is guaranteed always positive. I don't care for the absolute value. It would be a mistake to write the absolute value on x squared. However, there is a third option. What is the answer now?
It would be the absolute value of x to the third.
Exactly. Because x to the third could be negative. And I need to make sure that that's not going to happen. So here's my note. Even root, comma, but the answer could be negative. Therefore, must use absolute value if x can be any real number. So 3 options. Odd index, don't care. Even index, the answer positive, don't care for the absolute value. However, if the index is even, but the answer could be positive in the case of when x can be any real number, that I must use the absolute value. It's a must. Even root, but the answer could be negative, then I must. It's a must to use the absolute value. Okay, so now we're ready to work on this on page 594. I would like to start with 47. On 594, the square root of 4x squared. Now careful, the requirement is simplify. Assume that the variables represent any real number. So I will split it as like I did before. I'm allowed to. And then I'll say the square root of 4 is very good. But now I have to think. I am told that x can be any real number. What do I write as the answer of the square root of x squared?
The absolute value of 2x.
I already took 2 outside because of that reason. 2 does not belong inside the absolute value. Very good. What about 49? The cube root of x to the third. X can be any real number. What will you say as the answer? Remember to go through these 3 options. Which option is this? Number 1, number 2, or number 3? Which one? Yes. So what is the answer? That's it? Very good. Excellent. 51. I have the square root of x minus 5, everything squared. Before I write the answer, I go through my options. Odd root? No. Even root? Yes. There are 2 options for even roots. If the answer is always positive, I don't care for the absolute value. If the answer can be negative, I must write the absolute value on the final answer.
So just X minus 5.
Okay, let's go through the options one more time. So either this or this. Can the answer be be negative? Then it's this. If the answer can never be negative, then it's this.
It's kind of positive.
So what will you write? And let's discuss it. Let's write it first. I know you know.
The absolute value of x minus 5.
Very good. Because x minus 5 can be negative. Let's say x is 3. 3 minus 5 is negative 2. Therefore, I have to use the absolute value. Now, what about this situation? What will be the answer for this?
Parentheses x minus 5 squared.
Do I need the absolute value of x minus 5 squared?
No.
It's always positive. Very good. Excellent. Okay, 53. The square root of x squared plus 4x plus 4. I'm going to tell you what I would like to do, and you say yay or nay. Bless you.
No.
No.
Why?
Yeah.
Why? Why can't I do that? Why can't I do that? Because they are added terms, 1, 2, 3. It's not a product, it's not a ratio, and I'm not allowed to split the radical when I add terms or subtract terms. Is that clear? That would be a terrible mistake. Very good. So then what can I do? If that is not allowed, there must be a way. And we have a contract that we signed a month and a half ago. This is our contract. I no longer have that lecture. I recycled the paper. Any suggestions? Yep, it was a long, long time ago. And we wrote contract. And there were 3 formulas there.
Is X minus 2 whole squared?
S.
Excellent, thank you very much. Very good. X can be any real number. What will be the answer?
Parentheses x plus 2 squared.
We already wrote that.
It's just x plus 2.
Careful. The absolute value of x plus 2. Because if x is negative 3 plus 1 plus 2 is negative 1. Very good. Okay, 71. The square root of x to the 20th over 4y squared. For this problem, we are told, assume that all variables represent positive real numbers. What does that mean? It indirectly tells us, forget about, exactly, there's no need. Everything is positive. So we got a break. No worries. So what do? First, I split the ratio. Square root of x to the 20th, square root of 4, square root of y squared. I split the ratio at the top and the product in the denominator. There is no sum or difference. I'm allowed to do this. I wasn't allowed here, but I'm allowed to do this. So the top, assuming everything is positive, the top is
X to the power 10.
Good. The square root of 4 is,
4y.
and the square root of, yes, it's 2y. If y were any real number, then I would have used the absolute value on y. Would I have used the absolute value on x to the 10th? Can x to the 10th be negative? No. So I would have not used x to the 10th is always positive. It's an even power. Okay, I have 3 more minutes. Let me choose one more problem. Let's say 75. The fourth root of x to the 4th over 16. So this is the fourth root of x to the 4th over the fourth root of 16. The top is, we are told everything is positive. So the top will be, very good, and the bottom will be 2. So the first, as I said, 5 sections will only deal with rules till we get to section 10.1.